In this lecture, you're going to learn about subnet masks. And you can see what I've done here is I've opened up a command prompt on my Windows laptop again, and I've entered ipconfig, and you can see where I've highlighted it that my IP address is 192.168.10.15. My subnet mask is 255.255.255.0, and the default gateway is 192.168.10.1. So every host in your network is going to know what its IP address, its subnet mask, and its default gateway is. Let's now see how it's going to use that information. So onto the slides now. A host can send traffic directly to another host on the same subnet via the switches that they're attached to. But for a host to send traffic to another host in a different subnet, it must be forwarded by a router. So our routers are our devices that link our different subnets together and route the traffic between them. The host, therefore, needs to understand if the destination is on the same or a different subnet in order to know how to send it. If the destination is on the same subnet, it will send it there directly. If it's on a different subnet, it knows that it has to send it to the local router, which is the default gateway. And the way that the host knows whether the destination is on the same subnet or a different subnet is by comparing the IP address of the destination to its own IP address and subnet mask. The subnet mask, just like the IP address, is also 32 bits long, and it can be written in dotted decimal notation, the same as our IP addresses, or it can be written in slash notation. You'll see how that works a bit later in this lecture. A host's IP address is divided into a network portion and a host portion. And it's the subnet mask that defines where the boundary is between the network part and the host part of the address. And the easiest way to explain how this works is by giving you an example. So let's say the host's IP address is 192.168.10.15 and the subnet mask is 255.255.255.0. That's the IP address and subnet mask that's actually on my laptop. To figure this out, we write the IP address out in binary notation, like you learned in the last lecture, and then the subnet mask also in binary notation underneath. So our example was 192.168.10.15, subnet mask 255.255.255.0. So you see the top part here, I've written 192.168.10.15 out in binary, and then underneath 255.255.255.0 out in binary as well. The IP address is compared or masked with the subnet mask. A 1 in the subnet mask indicates that bit in the IP address is part of the network address, and a 0 indicates that the bit is part of the host address. So very quickly you can see here all the 1s on the subnet mask go up to here. Everything in the IP address above that is part of the network portion of the address. The 0s above that in the IP address, those are part of the host portion of the address. Let's make this a little bit clearer. So subnet mask 255.255.255.0. With the subnet mask, it's always going to have contiguous 1s, and you see the 1s come up to this part here. So I put a line in. That line is the border between the network portion and the host portion of the address. So in the example, the network address portion is 192.168.10, because on the IP address, from here on the left all the way up to the line, that is 192.168.10 part of the IP address. Whatever is after the line is the host portion of the address. So in our example, it is the .15 is the host portion of the address. And I've highlighted it there. There is the network portion. If the host wants to communicate with another host with an IP address, which also begins with 192.168.10 in our example, so say for example that this host wants to send traffic to a destination address of 192.168.10.20, it knows it's on the same subnet and it can send the traffic directly because the destination also begins with 192.168.10. If this host wants to communicate with another host on any other network, anything that does not begin with 192.168.10, then it knows it has to send the traffic via a router. So if it was sending traffic to destination 192.168.11.20, for example, it doesn't begin with 192.168.10, it's a different subnet, sends it via the router. For a destination address to be on the same subnet, the network portion has to be exactly 192.168.10. Anything else means it's a different subnet, we have to go via a router. The subnet mask always begins with a contiguous block of ones. This is different than the IP address. You see our example IP address here, it's 11000000100101. So with the IP address, the ones and the zeros can be mixed about in pretty much any order. The subnet mask is a block of ones and then a block of zeros, always. We never mix the ones and the zeros up with each other in the subnet mask. So 1111.1111.1111.0000.000, etc. is a legal subnet mask. 111.011.01, mixing up the ones and zeros, we can't do that. That is not a valid subnet mask. The host portion of the address is available to be allocated to the different hosts on that particular subnet. For example, your PCs, servers, printers, router interfaces, switch management addresses, etc. With two exceptions that you'll see coming up after the next slide. So there's the host portion of the address for our example highlighted. The host portion of the address specifies the individual host and must be unique on that subnet. Your hosts do not need to be numbered sequentially. For example, we could have a subnet with two hosts on it. One could have address 10.10.10.10, the other could have address 10.10.10.20. We don't need to number them .1 and .2. You can't have two different hosts both with the same IP address. For example, we couldn't have two hosts both with address 10.10.10.10. That would be a duplicate address. And whenever any traffic was sent to 10.10.10.10, your network devices wouldn't know which host to send it to. So that's illegal. You can't have duplicate IP addresses. You could have host 10.10.10.10 on one subnet and host 10.10.20.10 on a different subnet. They're different subnets, so it's not a duplicate address. That's just fine. All zeros in the host portion designates the network address and is not allowed to be allocated to a host. Remember, we just said a minute ago that there's two particular addresses that cannot be assigned to a host. The first one of those is all zeros in the host portion. That designates the network address or the network ID. In our example, the network address would be 192.168.10.0. So we fill in the bit pattern in the network portion. So that was 192.168.10. And then in the host portion, we put all zeros in there. So all zeros, you can't assign it to a host. It signifies the network address, which is the bottom address in that particular subnet. And there's it highlighted there. You can see we've used all zeros. The other address which cannot be assigned to a host is all ones in the host portion of the address. So all zeros signifies the network address, which is the bottom address in the range. All ones, which is the top address in the range, that is the directed broadcast. Whenever you send traffic to the directed broadcast address, it goes to all hosts in that subnet, not to an individual host. So we can't assign that address to an individual host. And there it is highlighted, the host portion, I've put all ones in there. So that leaves 192.168.10.1 to 192.168.10.254 in our example available to be allocated to our different hosts. So all the different PCs, other kinds of hosts, maybe we've got some Windows PCs, some Linux PCs in that subnet, I can number them from 192.168.10.1 all the way up to 192.168.10.254. They're all in the same subnet. Whenever they send traffic to each other, they can do that directly without going via their default gateway router.